Hello, and welcome to this tutorial on creating shake shingles for 3D printing using generators. I like to characterize the end product of this generator as organic, in that each shingle differs in width, height, thickness, angle, and horizontal separation from each other, like I would expect on a roof or wall of cedar shingles, each nailed by hand. The generator makes this possible by allowing you to specify minimum and maximum values for these 5 parameters, and the software then randomizes the shingle attributes within the ranges you specify. Just as a reminder, my generators are available for downloading at my website, daacm.github.io. Right below my introduction, there is a table of contents, and in the entry on Automating CAD is a link to download a zip file containing all the executable files. Before discussing the generator, we need to make a few assumptions. We will assume that you have successfully downloaded the generator's zip file, extracted the executables, virus scanned them, and launched the Shake Shingle generator. We will also assume you have learned how to post-process the SCAD files through the Open SCAD program to create Stereo Lithography files. If either of these assumptions is not correct, please watch the tutorial on creating a basic building, where these concepts are introduced. As a reminder, the default values of all parameters represent good starting values, and if you are new to a generator, I recommend starting out by just clicking on the green Generate button to see how things work. The green button will ask you for a location to store the SCAD file, which contains 3D instructions to create your desired object. And to terminate the generator, just click on the red Exit button. The maroon and blue buttons load and save the configuration parameters respectively, and the orange button restores the default values. Let's take a close-up look at the end product of the Shake Shingle generator. First of all, it creates only one side of the roof. You will need to print it twice and glue together, or import one side into a CAD package like Tinkercad, and then copy and paste the pair. Note how each shingle is a bit different from its neighbor, just like you might expect in real life. The input form will let us specify ranges for each parameter, and the generator will pick random values within each range to get that organic look. Now let's see how this is done. Starting in the upper left, we can specify the width of a shingle panel, the distance from the front to the back in millimeters. The next parameter, the number of rows, is a bit obscure. When I wrote this generator, I decided to not specify a panel height, but to ask you for the number of rows you desire and the vertical offset between rows. Thus, the height of a panel is approximately the product of the number of rows and the vertical offset, or in the default case, approximately 15 times 5, or 75 millimeters. I say approximately because the whole point of this generator is to generate an organic roof, where the width, height, thickness, angle, and horizontal separation of each shingle will vary slightly from every other shingle. And as the height of the shingles on the lowest row varies, so does the height of the overall panel. To provide an accurate value for any given set of input parameters, the notes box will always give you the exact height. Continuing along the top row of input parameters, we see the substrate thickness, which represents an underlayer on which the shingles lie. Think of it like subroofing under the shingles. I like 2.0 millimeters for HO, but you probably could go with as little as 1.0. Now let's jump down a row and consider the sets of minimum and maximum values which define the limits of randomization, giving us the organic looking roof. The minimum and maximum horizontal offset pair represents the separation between shingles in a row. The default values of 0.20 and 0.50 millimeters allow for a gutter between shingles. I normally print my models on a filament printer, and these values look good to me. You are allowed to make minimum and maximum values the same to eliminate the randomization of a value pair, and there are times when I have done so to get a special effect, but as always, the default values are good starting points. On the fourth row, we find pairs that control the range for the shingle width in millimeters. The fifth row contains a pair for shingle length. The sixth row, shingle thickness. The seventh row will eventually allow you to control the angle of the shingles, but for now, I am pegging that value at 7 degrees. Now let's move on to the parameters which are not related to the organic look. Jumping back to the second row, we have two parameters which control the overall pitch of the roof. Some common values appear in the roof pitch. I strongly suggest that you keep checked the box which bevels the top edge. Doing so makes it much easier to join two roof panels into a single shape. And take a look at the tip and trick for joining flat roofing panels. The same technique applies for shake shingle roofing as well. Returning to the bottom row, we have controls which allow shingle rolls to be ragged on the right, a feature I do not recommend. And we have a checkbox to enable tab regularity. I put this feature in before I had tab shingles in the flat roofing generator as a quick and dirty way to get tab shingles, and I left it in for backward compatibility but don't recommend its use. While you can print a pair of shake shingle panels and glue them together, I like to align a pair in Tinkercad, group them, and then stand the group on end for printing using a brim in the slicer. This prints fast and stable, at least for me. I usually print them in a brick color and then dry brush a small amount of complementary acrylic paint. Or sometimes I print with wood impregnated filament and color with wood stain or apply washes. The choice is yours. That's all I have to show you. This is a fun generator and especially useful for A-frame cottages using a roof pitch of 60 degrees. I use Tinkercad to create panels of windows for the front and back walls, and you should consider the flooring and pier generators to create a deck. Have fun!